Here. Today we're going to be working on permutations. So we're doing Unit 7, Notes 2. So let's go ahead and let's jump right into what this permutation concept is, and then we're going to start actually using it. So it says the manager of a copy shop needs to hire 2 employees, one to work at the counter and one to work at the drive-through window. Katie, Bob, and Alicia all applied for jobs. And how many ways can the manager place them? Okay, so first of all, I'm going to have this column be the drive-through. Let me put it in the order of the word problem here. This one be the counter, and this one be the drive-through. So when we're at the counter, I could have Katie working at the counter, Bob working at the drive-through. I could have Bob working at the counter, and Alicia working at the drive-through. I could also have Katie working at the drive-through, or the counter, while Alicia works at the drive-through. Okay, while I have Bob at the counter, I could have Katie working at the drive-through. Then, while I have Alicia working at the counter, I could have Katie working at the drive-through. Then, when I have Alicia working at the counter, I could also have Bob working at the drive-through. So we have 1, 2, 3, 4, 5, 6 different ways that this could happen. Okay, so that's what we're going to learn to be calculating out. Now, writing all of those options out took forever. So this is going to be shorter mathematical ways of doing this. So let's go ahead and let's take a look at what a permutation is. Okay, when a group of objects or people are arranged in a certain order. So this word arranged right here is really important because with permutation, the order matters. So that's going to be important to remember coming up here. So yet another thing is, like I just said, order is important. So if we talk about A, B, or Alicia and Bob, that's different than Bob and Alicia. Okay, so just think about that moving forward and remember throughout this entire note sheet that for these problems, the order does matter. So let's take a look at this one. How many different arrangements are there for the letters in the word triangle? Well, the first thing I want to do is count how many letters I in fact have. Okay, for the word triangle, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 letters. Are any of them repeats? No. So I'm going to write 8 spots. 3, 4, 5, 6, 7, 8. So when I start off for the first spot, I have 8 letter choices. Then I'm going to choose a letter. So when I go to the second spot, I'm only going to have 7. And then I'm going to choose another letter. So when I go to the next spot, I'm going to have 6. And then 5, and then 4, and then 3, all the way down to 1. Did I put 9 spots? I did. No wonder I was so confused. Okay, so you only should have had 8 spots there. So then, in order to figure out the number of ways, what we're going to do is multiply. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So when I multiply all the way down that way, what I end up getting is 4,320. Okay, so 4,320. Now this concept is known as a factorial. Okay, when you multiply all the way down, which is something that you somewhat saw on the previous note sheet. So this is the same as 8 factorial. Now let's take a look at the next one. How many different arrangements are there for the word triangle? Again, 8 letters. If the first letter has to be A. So now I'm going to go ahead and draw my 8 spots. And I promise this time I'm actually going to draw 8 spots, not 9. So I'm saying, okay, this guy right here has to be an A. Well, how many ways can that guy be an A? Just one. But now we've chosen one of our letters and we say, okay, A is first, and there's only one way that can happen. But then we still have 7 options for the next one because we don't care. Then we're going to pick a letter, then we only have 6 options. So this is really the same as the previous problem, except it's only going to be 7 factorial instead of 8 factorial because we picked that first spot as A. So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1 is going to give us 5,040 ways. So that's your final answer for number 3. Now let's take a look at number 4. We want to figure out the license plates are made up of 6 characters, 3 letters, and 3 numbers. So we want to figure out how many different license plates can be made in the state of Minnesota. So first of all, let's take a look at letters. So first you're going to have 3 letters in a row. Okay? And you can repeat letters. If you look at a license plate, I saw ones that was just E, E, E. Okay, so you can repeat letters. So the first 3 spots are letters, and the next 3 spots are digits. Okay, so let's start with letters. So to figure out the combination of letters, well, we need to figure out how many letters are in the alphabet. And there's 26 letters. Now I said that letters could repeat, so we have 26 choices for each of our letter spots. Now let's think about digits. This is what confuses people the most because they think, okay, there's 9 digits. Well, don't forget that 0 is also a digit. So technically, there are 10 digits that also can be repeated. So there's 10 options for each of those. So then in my calculator, I'm going to do 26 times 26 times 26 times 10 times 10 times 10. Now, when I do that, I end up getting 576,000 ways. So that's pretty awesome, right? Because that's how many license plates can be made. Which if you actually think about it, there's probably more cars than that globally, or at least in the United States, right? So let's go ahead now and let's talk briefly about the permutation formula itself. It's really, really important that you guys have this written down, okay? Because it's something that you can put on your cheat sheet for your final and so forth. So N is going to represent the total number of objects that you have. N is always going to be on the left side of your permutation. So look down at that formula. N is always on the left side, and it's always greater than or equal to the number of objects that you are choosing, which is R. So R represents the number of objects that you are using or number of objects that you are trying to put into an order. Okay, so N is always bigger or equal. If you do it the other way around, it will not be pretty and it will not work. So just remember that. So let's start by just kind of applying the formula here. So we need to evaluate 5p3. So 5 is on the left side, so I know I'm going to have 5 factorial on top, and then I'm going to have 5 minus 3 factorial on the bottom. So 5 factorial divided by 2 factorial. So now I'm going to go ahead and write that out. So 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. So I can cancel out 2 and 1 because they're on both the top and the bottom. So now I want to do 5 times 4 times 3. And when I do that, I end up getting 60. So 5 permutate 3 is going to be 60. Now let's take a look at number 6. So for number 6, we have 7p2. So on the top, we're going to have 7 factorial. And on the bottom, it's going to be the difference between the two, 7 minus 2. Well, 7 minus 2 is 5. So I'm going to have 5 factorial on the bottom. So let's start by writing 7 factorial on top. Then on the bottom, 5 factorial. So then what I'm going to do is I'm going to cancel out everything from 5 on down because it's on both the top and the bottom. So all I'm left with is 7 times 6 on the top. Well, 7 times 6 is equal to 42. So 7 permutate 2 is going to be 42. Now let's start applying that to some word problems. So here it says that there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? So let's think about this scenario. The order does matter. For sure, a bronze medal is different than getting a gold medal, so it does matter the order in which you receive them. So we have 10 finalists that could potentially receive the award, but only 3 of them are going to actually receive it. Again, that 10 needs to go on the left-hand side. So I'm going to have 10 factorial on top, and then I'm going to have 10 minus 3 factorial on the bottom. So I have 10 factorial, and on the bottom I have 7 factorial. So start looking at it this way. Since I have 7 factorial, everything from 7 on down in that 10 factorial is going to be taken care of. Now, if you need to write it all out like so, like we've been doing, go ahead and do that. Cancel off what you need to. That's a great place to start. But think about it logically. Everything from 7 on down is going to be taken care of. So all I'm going to have left with on top is 10 times 9 times 8. Because again, everything 7, 6, 5, 4, 3, 2, 1 is going to be on the top and the bottom. So really all I have to do is 10 times 9 times 8. And when I do that, I get 720 ways. So the 720 ways that I can hand out the gold, silver, and bronze medals. Now imagine if you had to go through and actually write out all those different combinations. That would take you forever, which is why we use permutations. So let's take a look at number 8. It says a newspaper has 9 reporters available to cover 4 different stories. How many ways can they be assigned to cover the stories? Now some students say to me, well, order doesn't really matter then, does it? And it actually does. Think about it this way. If I had a story on giraffes, elephants, zebras, and tigers, and I assigned Susie to giraffes and I assigned Jerome to tigers, that would be different than if Susie had tigers and Jerome had giraffes. Okay, so that was kind of a tongue twister there. So in that way, the order does matter, which is why we're going to use a permutation here. So we have 9 total reporters, but we only have 4 stories that we can hand out. So we have 9, and we need to pick 4, and the order does matter. So on top, we're going to have 9 factorial, and then that's going to be divided by 9 minus 4 factorial. So then I get 9 factorial divided by 5 factorial. Again, think about this logically. Everything from 5 on down is going to be taken care of. So I have 5 times 4 times 3 times 2 times 1 is going to be contained in the top and the bottom. So I have 9 times 8 times 7 times 6. So when I multiply 9 times 8 times 7 times 6, I end up getting 30,024 ways. So that's your answer on number 8. So let's go ahead and let's take a look at number 9. Now, Miss Brisky was a Spanish teacher here a couple years ago, so you may not know who she is, but yet she's still here on my presentation. So Miss Brisky asks a pair of students to read statements in Spanish and then translate them to English. She chooses pairs from Jeff, Kathy, Chris, Anna, and Madison. So she wants to choose a pair. So it's different if Jeff is paired with Kathy versus Jeff being paired with Chris. Okay? So now let's take a look at pairing them. So we have 5 students and we're going to pair them into 2. So we're going to do 5 factorial divided by 5 minus 2 factorial. So then we're going to get 5 factorial over 3 factorial. So now we know that 3 times 2 times 1 are going to be taken care of in the factorial itself. So left we have 5 times 4, which we know is 20. So there's 20 different ways that Miss Brisky can make up those pairings. Now, last but not least, I'd like to briefly talk over permutations with repetitions. The permutation of n objects where p and q are alike is n factorial divided by p factorial and q factorial. So this actually seems like a super complicated formula, but we're going to go do some practice problems that should make it hopefully relatively easy for you guys. So let's go ahead and let's take a look. So how many ways can the letters Mississippi be arranged? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 factorial on top. Now we need to divide because you know what? An I is an I is an I. Okay, it doesn't matter how I change the order. If there's an I first, it's an I first. It doesn't matter which I it is. So we have to divide for the fact that some letters are repeated. So first of all, let's start with the I. So I count, there's 1, 2, 3, 4 I's. So I'm going to have 4 factorial on the bottom. And then I'm going to count, and there's 1, 2, 3, 4 S's. So I'm going to have another 4 factorial on the bottom. And then I have 2 P's. I find 2 P's, so I'm going to divide that by 2 factorial. Now I find that this can be complicated to try and simplify, so this is one that I actually just plug into my calculator. So first thing I do is figure out what 11 factorial is. So 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when I do that, I get 39,916,800. And then I'm going to take 4 factorial, 4 times 3 times 2 times 1, times 4 times 2 times 3 times 2 times 1, times 2 times 1. And when I do that, I get 1,152. So now I can go ahead and divide those two out. And when I do that, I get 34,650, and I'm going to write ways. Okay? Because that's how many ways you can calculate that out. So let's lastly take a look at this one. How many ways can the word geometry be arranged? So I'm going to count. There's 1, 2, 3, 4, 5, 6, 7, 8. Side joke for you. What does the acorn say when it grows up? Geometry. If you didn't get it, ask me in class. So there's the 8 factorial. All right. Then we need to figure out doubling letters up. So what I'm going to do is I notice that there's 2 e's. So I'm going to divide by 2 factorial. So 8 factorial divided by 2 factorial. What I'm going to get is 8 times 7 times 6 times 5 times 4 times 3. So when you end up multiplying all of that out, okay, notice I stopped and I didn't do 2 times 1 because that's taken care of with this 2 factorial on the bottom. So when you end up multiplying that out, you end up getting 20,160 different ways that the word geometry can be arranged. So that concludes your note video for today. Thank you for listening.